Hey guys, welcome to Safi Mixed. In this video, I want to use definition of derivative to find the derivative of a function at certain number n. That is, we know from the definition of derivative that the derivative of a function of f of x prime is given by limit h tends to 0 f of x plus h minus f of x divided by h. This is the definition of the derivative of function f of x. And we want to find the derivative at a number. Let me call that number n. So we want to find the derivative at a number n. The number n could be any real number, and we write the derivative at number n as f prime at n is given by limit h tends to 0 if n plus h minus f of n divided by h. So to find the derivative at number n, we first need to find the derivative at number n, we first need to find the function at a number n plus h, and then the function at number n. This is now a general procedure, and here I want to apply this procedure to a quadratic function of the form. You can take any function, but I just consider a quadratic function of the form x squared minus 4x plus something like 7. Okay, this is a quadratic function, and I want to find the derivative at number n. So first I need to convert this function into this form. That is, from this function I want to obtain n plus h. N plus h means I need to replace every x in this quadratic equation with n plus h. In doing that, I can write this as n plus h whole square for this term minus 4 times n plus h for this term, and then plus 7. I can simplify this by using the square formula. I can write this as n squared plus h squared plus 2 times n times h, and removing the bracket, in this term I can write minus 4 times n minus 4 times h plus 7. Now I want to write the function for this form, that is, I write f of n. So now every x in this relation would be replaced with n, and that gives me n squared minus 4n plus 7. So if I subtract this equation from this equation, I'll get this thing, the numerator of this equation. So I write if n plus h minus fn is in fact equal to this whole thing, n squared plus h squared plus 2 times n times h minus 4 times n minus 4 times h, and then plus 7. And then I'm subtracting this, so I will change the sign in this from minus n squared, and minus 4n would become plus 4n, and this plus 7 would become minus 7. So we see I can cancel this 7 with this 7, this minus 4n with this 4n, this n squared minus n squared with this plus n squared, and we are just left with h squared plus 2 times nh, this term, minus 4 times h. And since every term in this relation carries h, therefore I can take h common from this to write this as h times, so this would become h, this would become plus 2 times n, and this is minus 4. Now, if I substitute this value for this thing, that is the difference of the function at two different values, n plus h and n, and this defining equation, I can write the result in the form this equals limit h tends to 0, and for this I'm writing this, so it is h into h plus 2n minus 4, and then divided with h. This h cancels with this h, and putting the limit into this equation, this thing will become 0, so I'm left with 2 times n minus 4. So the derivative of the function that I just rub out from the definition of the derivative is 2 times n minus 4, or I can write this as 2 times n minus 2. So that's the derivative of our function. So this way you can use any function, whether that is a polynomial of higher order or a linear function or any kind of function, logarithmic, sinusoidal, whatever it may be, trigonometric. You can use this procedure to find the derivative from the definition of the derivative to solve the equation like this. At the end, thanks for watching.